Let's start looking at the topic number bases, and we're going to begin by examining base 10. Now, you can think of the base of a number as that number system that's used to represent the digits of the number when counting. Right? We're going to examine this thing about number bases using starting with base 10 and looking at some examples. I think base 10 is universally used nowadays. I think due to the fact that we have 10 fingers, that's what I read somewhere. That is most likely that we have 10 fingers, and we historically had been using our fingers to show the number of objects. So we have base 10. Alright, now the numbers or the digits that we use are from the Arabic number system. Now let's look at an example of a base 10 number. What example could we look at now? Suppose we have 15,976. Alright, let's look at that as an example. This is a base 10 number. When you write down a number, you don't have to specify that it's a base 10 number. That's a default number. Alright? So, let's break this number down and see what it is. This is 6 plus, alright, let's do it over here. From the right, it is 6 plus 70 plus 900 plus 5,000 plus 10,000. Let's add them straight and see if it works out. 10,000 plus 5,000 plus 900 plus 7 tens, which is 70, plus 6. So 6 and 0 and 0 and 0 and 0. It's 6. 7 and 0 plus 0 plus 0. That's 7. 9 plus 0 plus 0 is 9. 5 plus 0 is 5. And 1. Okay. So it does work out. It's 15,976. I'll just put a comma here, as is customary, to show the thousands. Okay, good. Now, what does this all mean? This is 6 ones, so we could say times 1, plus 7 tens, plus 7 by 10, plus 900. So it's 9 times 100, plus 5,000. So it's 5 times 1,000, plus 1 10,000. So this is 1 by 10,000. Okay, good. Now, suppose you consider this as this 10,000 as a power of 10. So it is 1 times 10 to the power of 4 plus 5 times 10 to the power of what gives you 1,000? 3. One shortcut way is to count the number of zeros that I have here. 4 zeros is 10 to the 4. 3 zeros, that's 10 to the 3. Plus 9 by 10. 10 to what power? Gives you 100. It's 2. Plus 7 by 10 to the power of 1. plus 1 by 10 to the power of, what would this be? Well, it would be 0. Yeah, 43210. So in this case, 10 to the power of 4 is really 10 by 10 by 10 by 10. You have 4 tens, 10 by 10 by 10 by 10, and then all of this multiply up to give 10,000. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Okay, good. And then 3 tens, and you multiply them out and you get 1,000. Multiply 10 by 10, you get 100. If you have 1 10, you get 10. And 10 to the power of 0 is going to be 1. When you raise a number to the power of 0, you get 1 as the answer. Alright, now let's look at this. You notice that 10 keeps occurring. You have 10 here. You have 10, you have 10, 10, 10. You have 10 common throughout. So basically, the significance or the value of each digit is determined by a power of 10. The least significant digits here. What am I writing here? You see, 1 should be 6. 6. It should be 6. 6 by 10 to the 0, right? The least significant digit here is 6. The most significant digit here is 1. Why? Because if you change each digit by 1, suppose you had you spent $15,976 using an electronic means of transaction, and they said to you, we're sorry, we had this 6, there was a mistake and it was increased to 7, but it's going to take 15 minutes to correct the transaction so that we can give you back your $1 extra that you spent. Right? How significant is that? $1. You could probably say, you keep the $1. I don't have the time, I have other things to do. But then, if this one was the one that they increased by 1 to 2, so instead of $15,976, the mistake was that you spent $25,976. This one changed to $25,976. Then in that case, you wouldn't just say, just keep the $10,000. I'll go my way. I have other things to do. The significance of this digit, just one digit change in it, would cause a big problem. Right? A one digit change from 6 wouldn't cause too much of a problem. 7 changing to 8 would be a bigger issue. That's $10. Changing this would be $100. Changing this one, the 5, would be $1,000, and changing the 1 to something else, each change would represent a $10,000 change. So this is the most significant digit. This is the least significant digit. Right? The 1 is the most significant digit, and the 6 is the least significant digit. Now, the significance or the position or the value of each digit is determined by a power of 10. Because what we're looking at is a base 10 system. Alright? So, this is what determines what base the number is. It's a base 10 system. Being that it's a base 10 system, each digit is multiplied by a power of 10 to show its value. Now, Another thing you can look at when you're dealing with base 10, a base 10 number system, what are the digits that you use to represent the various values? You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, there's no other symbol for you to use. After you reach the symbol that represents 9, then you return to the old symbols and recycle them. Keep using them back. 1, 0, that's 10, 1, 1, 11, 1, 2, that's 12, until you reach 19. When you reach 19, then you start using the 2, 2, 0, 2, 1, and so on and so forth. Alright? But the issue here is this: how many symbols do you have? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you use 10 symbols, you have run out of symbols. So in base 10, you will have only 10 symbols to use. After 10, then you start reusing those 10 symbols. Now later on, when we do other bases, the same argument applies. The same argument will apply. In base 2, you have only 2 symbols, and each value, each digit, the value of each digit will be represented by a power of 2. In base 4, you have 4 symbols, only 4 symbols, starting with 0, and then the value of each symbol in a number is represented by a power of 4. In base 8, you will have only 8 symbols, and the value of each digit will be represented by multiplying the digit by a power of 8. In base 16, same argument applies. You will have 16 symbols, and each digit will have a value represented by multiplying that digit by a power of 16, and so on and so forth. So the same arguments that apply to base 10 will apply to other bases. So we'll see about that later.